This is a response to a report of a 16-year-old girl who was severely burned due to likely overspent hours in the pool. Two preliminary causes of second-degree burn are pH levels and chlorine levels of the pool not constantly being checked, or the victim might have had an allergic reaction. Due to the total alkalinity and calcium hardness, less frequent checking and adjusting of pH levels, control problems, and possible problems with the pool's finishes can occur. Most pools, as everyone knows, have a pH level of 7.2. To contrast normal pH and pOH levels in a swimming pool, we can conclude that the pH and the pOH in the pool added up to 14 on the acidic scale. pH goes from 0 as acidic and 14 as basic, when pOH goes from 14 in basic to 0 as acidic. We interviewed a scientist named Benjamin Orr who is working on the issue. Let's go now to him live at the scene.
Thanks, Jake. Due to what we have examined, the skin reactions to the acidic level in the pool can be determined by what we call the KEQ, the equilibrium constant for a reversible reaction. We notice the equilibrium in the pool is off. The equilibrium shows the balance in whether you make products or reactants, which would explain whether or not the acid or base was stronger. When an acid or base doesn't completely break apart, it tells you the strength. We're also looking at the chlorine levels in the pool and determining how much chlorine they actually put in the pool. We came to the conclusion that the chlorine is amphoteric, or in other words, it can act as an acid or a base. There is multiple definitions of an acid and a base, but there are two main ones. Arrhenius doesn't need a hydrogen, while the Bronsted-Lowry needs a hydrogen.
Thank you, Benjamin. To conclude our report, we are going to continue research on this situation, and we ensure it won't happen again.